Welcome to Miss Ship's Imaginary and Complex Numbers tutorial. First, let's talk about what an imaginary number is. An imaginary number is I, which equals the square root of -1. So in the past, we've not been able to take the square root of any negative number, but now, because we know what I is, we can. But first, let's talk about the basic format of an imaginary and complex number. So I is our imaginary number. So if I have 2I, this is an imaginary number. If I have a number like 3, this is real, okay? So if we put them together, 3, say 3 plus 2I, this has a real part and an imaginary part. So we have something that is complex. So this is a complex number. So we have imaginary numbers, we have real numbers, and together they give us a complex number. The standard form of a complex number, standard form of a complex number is A plus BI, where A is the real part and BI is the imaginary part. For example, 2 minus 7I. 2 is the real part, and the imaginary part is -7, because I is the number square root of -1. Okay? Again, standard form, so if you see it like 7I, -7I plus 2, this isn't in standard form because we like to have the real part first. Okay, so just rewrite it that way. All right, so there's your overview of complex and imaginary numbers. Let's take a look at this guy. All right, so again, let's think of something we know the square root of. Square root of 25. That's 5, right? Or if we said, okay, so square root of 25 is 5. If I had x squared equals 25, and so you could tell me that this is 5, right? But is that the only number that x could be? So we know that 5 squared is 25, because 5 times 5 is 25. Anything else? -5. So -5 times -5 equals 25. So when I take the square root, because just cancel out, if something's squared, we take the square root, it cancels them out. I take the square root of both sides, but I have to take the positive and negative. So x is actually plus or minus 5, because it could be +5 or it could be -5. Okay? Same thing with square root of 64. +8 or -8, right? All right, so we need that information. That's a review of some information we need in order to do square roots of negative numbers. So if I have, let's start with the square root of -25. Okay. We're going to have 5 and -5, but the square root of a negative, I don't know how to do the square root of a negative. 5 times 5 is 25. -5 times -5 is 25. But I don't know what I do to get a negative under there. Well, that's where imaginary numbers comes in. All right, the square root of -25 can be broken down into the square root of -1 and the square root of 25, because -1 times 25 is -25. We know that this square root of 25 is either +5 or -5, right? Well, we go back, we defined I as the square root of -1. So the answer to this is plus or minus 5i. a little bit of practice and it starts to get easier. So another perfect square, negative 81. We know that square root of 81 is 9, and the square root of negative 1 is I, plus or minus 9I. Okay? Now, things get a little bit more complicated, of course, when you don't know, when it's not a perfect square. So you have to pull in some geometry and algebra 1 skills. All right, so let's take a look at square root of negative 48. Well, I know the square root of 36 is 6, and the square root of 49 is 7, but I don't know the square root of 48. So again, let's break this down. First of all, we know that we have the square root of a negative 1, so we can go ahead and pull that guy out. What else do we have? So let's look at, do you remember factor trees? That's a rhetorical question because you can't answer me. So let's talk about factor trees. Factors of 48. 12 and 4. Okay. So the point of a factor tree is to keep going until we get some prime factors. 12, 4 and 2. Not 4 and 2, 4 and 3. This 4 breaks apart into 2 times 2. Again, we can break apart this other 4 into 2 times 2. So now we have prime numbers. Remember, prime numbers are numbers where they only have factors of itself and 1. So I can break negative 48 into the square root of negative 1 and the square root of 2 times 2 times 2 times 2 times 3. So I'm taking the factors from underneath the factor tree, the prime factors, and I'm putting them under the square root. This here is equal to the square root of negative 48. So think about it. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 3 is 48, times negative 1 is negative 48. Okay? All right, let's keep going. The square root of negative 1 is I. Okay. All right, so when we're taking square roots of things, let's sidebar over here. The square root of 9 is 3, right? Because 3 times 3 is 9. Okay? So we have that pair, and that gives me 9. So here it's 2 times 2. Square root of 2 times 2, which is 4. The square root of 4 is 2. Okay? We have another pair. Square root of 4 is 2. So what's left on the inside? Square root of 3. Now I'll simplify this one more step. 2 times 2 is 4i square root of 3. If you didn't catch that, if you look back up here again, 2 times 2 is 4, times 2 is 8, times 2 is 16. Well, if all of these together is 16, we know the square root of 16 is 4. Okay? The only thing we need is that plus or minus. Plus or minus 4i square root of 3. Okay, let's take another look. Square root of negative 80. Okay, try this one. Pause me. Pause me now and try this problem. Did you pause me, or are you just waiting for me to do it? All right, if you didn't pause me, you need to do it now. All right, now I'm going to do the problem. Let's break this apart. Okay, first of all, I know underneath here I'm going to have negative 1. Let's break apart 80. It doesn't matter whether you do 2 and 40, or 4 and 20, or 8 and 10. You're still going to get the same thing at the end. Don't get me rhyming. I'm going to do, lost my marker. Oh, glitching. All right, we're going to do 8 and 10. All right, let's break apart the 8 into 4 and 2. 4 times 2 is 8. Break apart the 4 into 2 and 2. sure what's going on here. Alright, 2. I'm doing this with my mouse, so it's going to look awful. Alright, let's break apart the 10. 5 and 2. Okay, see if I can get my mouse back. Okay. Alright, so I have 2, 2, 2, 5, 2. Double check. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 5. Okay. So let's put all these back under here. We got 4 2s and a 5. Okay. Alright, so we have a pair of 2s here. We have a pair of 2s here. All of these together are 16. Square root of 16 is 4i square root 5. And of course, we don't want to forget our plus or minus. Okay. Alright, so those are a few examples to get you by. And hopefully soon I'll get to make you some adding and subtracting and multiplying and dividing.